good morning. Welcome to the multi-vendor interoperability event here at the EANTC booth. Today we have the last demonstration, actually focusing on SRv6 services, EVPN services over SRv6. In principle, a topic that we've tested for more than 5 years successfully already. But in this specific case, we're testing not only an ELAN, but we're specifically looking at multi-homing access, and we're looking at an all-active multi-homing. So there are a couple of challenges, especially in multi-vendor interoperability, when this kind of more complex ELAN service is activated over SRv6. And Cisco and Nokia are going to demonstrate the achievements and successes of this scenario together this morning. So I'd like to hand over to Diego Achaval from Nokia. Oh, Jiri. Okay, sorry. Jiri Chaloupka. Okay, whatever. You guys take the stage, please.
Thank you. Thank you. Thank you. Good
morning,
we will
everyone. Make it more interactive because it's last demo, so we will talk both of us.
So we'll make it fun. So the last day. Thank you for being here today. We know it's the last day, so it's going to be a bit heavy already during the week. So as Carsten was saying, we have been testing EVPN, and particularly EVPN MPLS for many years now. So in the past we have tested EVPN ELAN over VXLAN, EVPN ELAN over MPLS, and in each case we have also been testing multi-homing with multi-homing scenarios using different split horizon types. As you can see there, we have the local bias split horizon type, which is the one supported in VXLAN, and we have been using also ESI labels when the encapsulation is MPLS for EVPN, right? So what is new this year? So, well, as Carsten said also, in the past we have tested EVPN ELAN over SRv6, but in those cases we use single homing only. And this time we tested EVPN ELAN over SRv6 using multi-homing all active. And in this case, if we have to compare to MPLS and VXLAN, we have used SRv6 encapsulation, and this is the first time that we have tested using arguments attached to a segment routing v6 seed. In this case, also for the ESI label filtering mechanism or split horizon type for EVPN, particularly for multi-homing all active, right? And again, this is the first time that we have tested this ever, okay? So that's a cool new one for this year. So next slide. Thank you. So how does it work? So as you know, for SRv6, we have extended, at the IETF, people have extended route types in EVPN in order to include SRv6 information along those routes. So now the difference in this case, for multi-homing all active with arguments is that first, we signal a route type 1 route, which is in this case is the AD per ES route, and in that route we normally include the ESI label extended community, and that community carries a bit of information, right? So it carries the label that has to be used. So for MPLS it will be a regular label, but for SRv6 it's still a label, but that label is then transposed into the SRv6 seed, in order to build this the destination seed using arguments. So as you can see there, so we advertise, so the information we advertise in this route, first is the seed behavior, which is irrelevant for the receiving node, but then we also advertise the seed structure. And within the seed structure, the most important fields in this case are the argument length and the transposition length and the transposition offset, okay? So what we are going to do with that information, and also with the information we advertise in the IMET routes, which are the route type 3 routes. So we are going to take the seed, the NDT2M seed advertised in route type 3 routes, and we are also going to take the ESI label and the seed structure advertised in the AD per ES route, and we are going to transpose those bits into the seed that was advertised in the route type 3 route or in the IMET route. And with that information, we are going to build, as you can see on the right of this slide, we are going to build the destination IPv6 or the destination seed with the arguments. So what's the idea? What's the goal here? So the goal is to prevent layer 2 loops that are caused by boom traffic, and as you know, of course, boom traffic is broadcast, unknown unicast, and multicast traffic or multi-destination traffic. So as you can see, for example, in this simplified diagram here, if we have CE1 sending boom traffic over the link to PE2, and as you can see, the links in PE2 and PE1 that are connected to the CE1 are part of the same Ethernet segment. So if we have CE1 sending boom traffic to PE2, then PE2 is going to encapsulate that packet with an IPv6 header, where the IPv6 destination address is going to be the seed that you can see in there. So, and in the seed, of course, we have the locator, we have the function, which in this case is 16 bits. Remember that we have tested this with micro seeds, of course. And we also have the 16 bits next to the function bits in this case, as you can see there, right? So, and what is going to happen then in PE1 is that PE1 is going to receive that packet, is going to do a longest prefix match on the destination address, and before that happens, PE1 has already programmed that specific prefix in their forwarding table, and when they analyze and pass those specific bits, they are going to find out that that argument belongs to an ESI, and in this case, that is going to help PE1 to drop those packets instead of sending those packets down to CE1, right? So this is the theory, more or less, right? So now the next slide, we show, so we have two test scenarios in this case. The first test scenario is with Cisco replicating the boom traffic to different PEs participating in this EVPN service. And as you can see, in this case, the Cisco PE 342 is going to encapsulate that packet with SRv6 or IPv6, and then the Nokia PE is going to drop that packet and not send that boom packet down back to the CE, okay? And in the second scenario, we have a similar scenario, but in this case is the Nokia PE, right? So we have a couple of services in this case. I forgot to mention that. So we have two services, right? So one service is using a VLAN, the other service is using a different VLAN. But in this case, the only difference is that it's the Nokia PE that is the one replicating boom traffic over the EVPN network, and then we have Cisco 342 dropping those boom packets, okay? So now, I will hand over to Jiri here, which is going to start with the demo, right?
So perfect. The first, quick explanation here, just because we will be sending the ICMP, basically we will send a ping, right? From the CE, we will send the ping to the remote CE, and we will do the live packet capture, on the Linux server to see that it's fully transparent. Basically, we are tapping the wire, and we will do the packet capture. One quick clarification, right? Why you will see it as a broadcast, unicast, or multicast traffic? Because particularly for this, we disable the learning on or advertising the MAC address of the Node 352. So basically, Node 352 is right now not advertising on MAC address of the CE52. So basically, for both of the Ps, for Nokia and Cisco P, is basically unknown unicast traffic, because we want to flat and we want to show how will look the packet going to remote node, and how the packet will look like to going to the peer node, right? When we will see the argument and the BAM function and so on. So okay, let's go to the CLI. So first thing, what we will do is, I can show you that basically the packet is going through. First, as we said, we will be doing we will send a packet to the Cisco PE, and we will replicate the unknown unicast to the Nokia PE and also to the remote node. So you will see that the ping is basically going through, because then we will also get a reply. We don't care about reply at this moment. That's not important. So I'll just send a ping. So right now you can see that the ping is going through, but it's not most important. Let's right now go on the Linux machine, and let's do some live capture, right? So right now you will see that I will do the live capture on some Linux interface, and I will do the EVPN pickup file. So first I will turn on the capture, and we will see that I will be soon able to capture some packets. I will send it. So we see that we captured like 17 packets at this moment, 18. I will disable the capture. I will just change the rights to be able to download it. Let me go here, and we will download this EVPN pickup file. So you can see that this is the new one. I will go, and right now let's check, right? So first, what we can see here is the packet which is going to node 352, right? And if you remember, 342 is the Cisco PE, right? Doing the peering, the multi-homing with the Nokia PE, and 352 is a remote node. So if we will check it, we can see that FCBB 0, 352 is a locator, right? Part of the IPv6 header, IPv6 destination address, and then I have E001, which is, we expect right now, it's basically like the BAM function, which is advertised by remote node 352 over route type 3. So let's verify that this is correct first. So we will go on the Cisco PE 342 here. I hope that it will be visible, and we can check basically first we can check the bridge domain 1234, which is the bridge domain where we are replicating at this moment. And let's do show BGP L2 VPN, EVPN, some details of the route which we are receiving from the node 352. So let's find the 352. Yeah, this is this route. You see the route type 3, the first bracket. And let's sorry. Typo. So first, let's check the details, right? What is important? It's coming from 352, right, over the route reflector 353, which is not important in this case. And we are signaling a lot of interesting things here. But the most important here is like kind of like a label path, which is like E001, right? So basically, this 352 is telling, hey, if you will send me the BAM traffic, you have to impose basically this function. This is the same like a service label when we talk about MPLS, right? So let's check back on the pickup file, right? That we see this E001 here. So when we will go back, we can verify that on the pickup we see E001. And now it's important. I don't see anything after this one. People are getting excited. That's good. Okay, so let's check right now if we will have the packet which we are actually sending to Nokia P. Yeah, it's right, another packet obviously. So if we will look at it, it's again coming from 352, and destination address is FCBB 01058, which is locator of the node 58, which is Nokia P, where we are doing the multi-homing. Then I have something what is E02B, which I expect to be again the BAM function, and we will verify it right now. And now see one thing, there is a 1. And this is like really the exciting part, right? Yeah. This is the argument, right? I know it sounds like that we are excited from the 1, but it's really exciting, right? It's important to understand that we are not allocating another bits on the top of anything what we are saying. We are just modifying the bits in IPv6 destination address, right? So we are literally programming the information in existing bits which are already allocated, right? So nothing on the top. If you will calculate the number of the bits on the wire, it's all the time same. With MPLS, it's different. I need to add one more label when I'm sending it to my peer node. So let's verify this part. So again, we will look at obviously the same bridge domain 1234. And right now, what I will do here, I will not check the route type 3 of the remote node, but I check the route type 3, which is coming from the node 58, which is a Nokia P. So first, what we want to verify here, again, the attributes which are not important at this moment, but here is the function, right? E02B 0. So let's go back. If it's something what we are expecting. Exactly, E02B. So Nokia P is telling us, hey, if you are sending me some broadcast, unicast, and multicast traffic, now it's unknown unicast, be sure that you will put this function. And now it's important. Let's repeat it again. If I will send it right now to Nokia P, what the Nokia P will do, Nokia P may send it back to the C, so we'll create a loop. So now the important part is the argument, which is basically telling, when it's coming from this Ethernet segment, which we are multi-homing, don't forget to impose this argument. And now let's check how we will signal this argument. We are expecting 1 here. So we have to check again. The Diego explained it, but it's coming same as in split horizon label, right? In the route type 1 per ESI. So we have a route type 1 per ESI coming from route type 1. For this particular ESI, you can see that there is ESI 00, 52, 59, 52, and so on. This is the ESI which we configure towards the multi-home CE. It's important to know that the argument is really advertised for each of the ESI, because there can be another ESI where I need to send the bump traffic. So now, moment of truth. And when we will look at it, we can look at something what was called like a label value. And you see here 0, 16. So right now, it's like interesting, right? I have I see the value 16 and I'm expecting 1. What is happening? I have normally like a 20 bits, right? And if you will look at on the bottom of the route type, I'm also sending the SID structure. Right now, what's happening is that every single time when I'm advertising, I have to actually send also the information about what is my structure, how big is my function, how big is my argument. And at this moment, when we are doing the micro SID, we are using the 16 bits, right? You see that 16 bits is for function, 16 bits is for locator. So basically, we are shifted in this 20-bit value for the label. Therefore, you see the 16, which is 1, right? So 1, we just verified that this is working on the basically imposing from the Cisco to Nokia. Mm-hmm. And right now, let's do the same thing.
The other way around.
The other way around.
Perfect.
That basically we will send a ping, and the Diego will show how basically he's imposing the function and the argument on his side.
All right.
So let's maybe I will send a ping, and you will show the show commands.
Yeah, do it. Yeah. So in a moment, so while Jiri is sending that ping, what I wanted to highlight too is that on the Nokia side, we're going to be showing also how we signal all of this EVPN information using different route types. So I will show you that in a moment. There you go.
Okay.
So send it. Yeah.
So again, I'm doing the pickup file evpn2.pickup. I'm turning it on, and right now you see that I'm changing the IP address from 10.10.10 to 11.11.52 because we know that right now it will go to the Nokia side. So we can see that the capture is running. I'm sending again the ICMP true. So let me stop the capture. Let me again change the rights here, and let's go to capture the packet. See the packet here, EVPN2 pickup.
Excellent.
And perfect.
Thank you.
So right now we can see that there is also some another stuff going on. And the first, I will show here. Let me first go the packet which is sent from 58 to, we will here see only like with the argument which doesn't matter in this moment. So let's see, from 350, so from node 58, it's coming to the node 342, and again Diego will just verify that he's expecting here the function E003 and argument 1 again.
Exactly.
Right?
All right.
So I will let Diego to show the output on his side.
Thanks, Jiri. Right, so this is going to be very quick here, I hope. So first of all, I wanted to show you the route type 3 that we received from the other side to show you the boom function, right? So in this case, show route BGP routes EVPN, inclusive multicast, and in this case, the community is going to be 1235, 1235. So you see we have a few routes in there. So if we check the details, so what we receive from node, so you see here, for example, that we receive the bump function in this case. So it's not this one, should be the next one. One moment, please. So as you can see here, so this is what we received from the Cisco node. So you see here, this is a row type 3, and you see the behavior, and you see the structure, and you see the seed that we received from, well, the locator and the seed that we built after transposition, right? So as you can see here, this is the end, end micro DT2M. Sorry, these names are very difficult to remember. So, okay, perfect. So that's one. So as you saw in the packet capturing a moment ago, so this is one part or one portion of the seed that we are using in the destination address in the IPv6 header, okay? And now what I wanted to show you are the auto discovery routes, in particularly the auto discovery per ES routes. Yeah. So we need to check the ones coming from 353. So this is going to be here. Perfect. There you go. So no, not this one. Sorry.
41.
Be, yeah, some of these ones. Yeah. Okay, this one exactly coming from 342. So as you can see, so we don't have any seed in here. As you can see down here, we don't have any seed advertised because, of course, as I was mentioning at the beginning, the seed that we are going to be using to transpose the ESI function into, or the arguments into the seed, is the seed advertised in the row type 3 route, right? So, and as you can see, we receive the ESI label, value number 1, and we receive the seed structure. So as you can see, the argument length is 16, the transposition length is 16, and the transposition offset is 16. So in this case, what this node is going to do is transpose those 16 bits signaled in the ESI label, extended community, and transpose those bits into the seed next to the function. So in the bits after the 64th bit yes. in the seed. Okay. So and just going back to the capture, yep. As you can see here. So this is what we were showing before, right? So we have the boom function, okay, and we have the arguments. Okay. So this is it. I think. I don't know, Jiri, if you will like to add something else, but
yeah, I think that you know, in the end of the day, we show that EVPN is cool.
EVPN is mega cool. Sadly, it was put at the end of the show. So, but yeah, excellent.
Perfect.
Thank you very much for being here today. Cheers.